Welcome to this session. I would like to discuss the solution for the CAT that we did on 8th December 2021. This specifically for the group of mechanical engineering students, University of Nairobi. So the first question in this CAT was, so question 1, if the universal set U is given by these elements 1, 2, 3, 4, and 5, and we have the subsets S and define these subsets S to be the set with elements 1, 2, 3, and the set T has the elements 1, 3, 5. And then find there are two parts, S complement, and then number 2, T complement. Now, these are very good problem, an appetizer problem in this CAT. So once we know how to define a complement, so a complement of the set S simply means all those elements which are not in the set S, but are within the universal set U. So therefore, the solution to the first part, S complement, will be given by the set of elements which are in this universal set U, but not in S. So 1 is in S, so 1 cross 1, 2 is in S, 3 is in S. So which means that the elements which are remaining in the universal set, once we have taken out all the elements in set S, are only 4 and 5. So therefore, the set S complement has two elements, 4 and 5. And then number 2, T complement. Now for T complement, the same thing, you identify those elements in the universal set that are not in the set T. So 1 is in T, so you cross 1, 3 is in T, so you cross 3, and 5 is in T, you cross 5. So the only remaining elements are 2 and 4. So therefore, the set T complement has elements 2 and 4. So that's the solution to that first problem. And then second part, number 2, our second question in this CAT was given give the Venn diagram of the following following sets. So the first part was A minus B. Second part was B minus A. Third part was A complement intersect B. Now, you can do this question, or you can give the Venn diagram in 2 ways. One way is to draw the universal set and then represent universal set by the rectangle and then represent the sets by circles. Or you can just use circles alone to represent the Venn diagram. So part 1, A minus B, means the set of all those elements which are in set A but not in B. So if this is our universal set, so let this to be our universal set U, and then let this be set A. Let this be set B. So this is A, then this set B. Now, when we say A minus B, we mean the region in set A that is not part of B. So it will be this part. So the region I'm shading is what defines A minus B. So this is the required region. Or you can show this same set by just drawing this as your set A, and then you draw this as your set B, and then shade the required region. The required region is this part, which is in A and not in B. So that's the first answer to the question, answer to the first part. And then B minus A, let this be the universal set. And let's now draw the sets inside. So let this be set A. And then let's draw this as our set B. Now, B minus A means the region in set B, not in A. So this part. So this part I'm shading is what defines B minus A. Or you can just draw the two circles. This to be set A, and then draw set B. This set B, and then you shade this part. So this defines B minus A. Similarly, this is what defines B minus A. And then third part, we were to show the region A complement intersect B. Now intersection means the joining joining two sets together, or a region that's common to both sets under consideration. So if this is our universal set, U, then in this universal set, we draw two sets. Let's call this one A, and draw another set, call it B. Let this be set B. Then, when you say A complement, means this region outside set A. And then B is this green circle. So region which is outside A and common to what is in green circle is actually this part. So you shade this. This is a region that is outside A, but within set B. So A complement intersect B means the region that is common to set B and what is outside A. So this is this part. And because this part is just within these two, within the region defined by two circles, not outside the universal set, then we can as well represent the same as saying, if this is A, and then this is B, then A complement intersect B is this part. So you see A complement intersect B is the same region as B minus A. So this would be the required region. And question 3 in this cut was, let this question 3, let A be the set with 3 elements A, B, and C. Let B be the set with two elements, D and E. And let C be the set with elements A and D. So find, there are three parts, four parts, A cross B, B from part 2, B cross A, from 3, A cross B union C, and then lastly part 4, we have A intersect C cross B. So remember that to define A cross B is simply the set given by pairs of elements A, B, such that A is from set A and B is from set B. So this is how we define the cross product. So when you say first part, A cross B, means we find all those pairs of elements from A paired with elements in set B. So now when you come to A, it has A, B, and C. So we'll say this A is paired to D, as the first element, and then same A can be paired to E. So I finished the pairing of A with the elements in B. We go to B, B paired with D, and then B paired with E. Lastly, C paired with D, and then C paired with E. So that will be the solution for A cross B. Now, when we go to B cross A, now we are starting with B elements pairing with A elements. Remember, Cartesian product is very sensitive to order. So B cross A means now the starting element in the pairs will be those from set B. So B, let's pick D, is paired with A, and then D is paired with B, and then D is paired with C. So I finished taking D as the first element, pairing with all the elements of A. Then we go to E paired with A, E paired with D, paired with B, and then E paired with C. So that is the solution. Please note that the element A, D is not the same as D, A. Just for example, if you are to plot a point like 2, 3 in the Cartesian plane, and then point 3, 2, you see these points are at different locations. 2, 3 means X value is 2, Y value is 3. 3, 2 means X value is 3, Y value is 2. So AD is different from DA. So therefore, from this result, A, D is different from D, A, and similarly, A, E is different from E, A. So A cross B is different from B cross A in this given setup. And actually, in general, most cases, when we change the order of Cartesian product, then the answer is different. Now, part C, or part 3, we need to define A cross B union C. Now, this is the same as A has elements A, B, C cross. Now, let's get B union C. B union C means all elements in B or in C or both in B and C. So B is this set having elements D and E, and the set C has the element A and D. So the union of these two sets will be simply the set having elements D, E, and A. You don't have to repeat D again because D is already written. So when you repeat elements in the set, that's not generating a new element. So therefore the union is DE, comma A. And so A cross B union C will be given by, now we'll start with A, pair with D, A paired with E, A paired with A. So we have done with this A, let's go to B. B pair with D, B pair with E, and then B pair with A. Then next element, C paired with D, and then C paired with E, and lastly C paired with A. And if you count the number of elements in this new set should be the same as the number of elements in this set times the number of elements in this set. So this has 3 elements, this has 3. So 3 by 3 is 9. So the total number of elements in this Cartesian product should be 9. So this 1, 2, 3, 4, 5, 6, 7, 8, 9. That should be the case. And then part 4, we have to define the Cartesian product of A intersect C cross B. So the first thing, define A intersect C. A has the elements A, B, C, and C has the element A, D. So what is common to A and C is only element A. So the same as the set with only one element A cross the set B has 2 elements D and E. So the Cartesian product for these two, for this set A intersect C cross B will be given by A paired with D and then A paired with E. So that is the solution to that part. So the next session will give the solution to question 4, which was testing on relations and functions. Thank you.